Hello, everyone, and welcome to another stream. My name is Luciano.
And I'm Roberto.
So, in this channel, we have been streaming a lot of different stuffs, but mostly trying to learn Rust. So, we have done a lot of Advent of Code in Rust. We have been doing a little bit of game development using Bevy and Pygame. So, also comparing the experience of building games between Rust with Bevy and with Python with Pygame. And today we want to try to do something a little bit different. We want to explore a specific Rust library called Nom, which allows you to create Parser. And it could be a very interesting thing to learn, especially going back to Advent of Code, where you have to parse a lot of different kind of styles of input and extrapolate data from text files. When you're doing that in Rust, either use regular expressions, and we will talk about what are the pros and cons of that, or you build your own parsers. And Nom could be a good library if you decide to build your own parser.
You forget that you can be super dumb and split strings like crazy.
Exactly. That's I would call
The
it
entry level.
creating your own parsers, but in a very naive way. Nom
Yeah.
allows you to do that, but in a more structured way. So we will also hopefully discuss that and understand the differences. Before going ahead, keep in mind that all the recordings are available on YouTube if you're curious to check our previous sessions. So this is the link. Let's see if we can also put it on screen. So feel free to go there and check it out. Okay, so let's get started. Let me share my screen and we can look at Nom. So this is actually the project. Let me also post this in the chat. And basically, this is the repository. It's an open source project, as most of the Rust crates. So feel free to check the code, contribute, whatever you want. Now, let's have a quick look at the README just to get a feeling of how to use it. So basically, Nom is based on the idea that you are incrementally consuming your input. For instance, you can use it to consume all kinds of inputs. It doesn't have to be a string. It can even be a binary. It can even be your own custom type of input. Generally, we're going to be dealing with strings, at least for today, but keep in mind that it's built to be a very generic kind of parser. And there are also examples of people that implemented like video codec, video files parser with Nom. So it's very flexible, it's very powerful if you want to use it. Now, in this particular example, the author of the crate want to show how to parse hexadecimal colors, for instance, the ones you will find in CSS. And what they are doing here, they're basically defining a generic struct. And then from a string, you will be able to basically, if you can parse correctly a color, it will be populating a struct that looks like this. By the way, thank you very much for the follow, Boil Squid. We also have some spam that I don't know how to delete. So ignore the spam for now.
I don't know how to delete that too.
I wish that from the Twitch admin you could simply delete spam rather than going into the moderator mode. Anyway. Okay, back to the example. So the cool thing about Nom is that you can define parsers and subparsers. Generally, your complex parsers are a combination of multiple parsers. And a single parser is effectively just a function that looks like this. So it takes an input, which in this case is a string, is your input type. Here we have a string slice. And it always returns this kind of thing, which is an iResult, which is a special kind of result from Nom. And iResult basically returns another string and some value that is the result of that parser. For instance, here we just want to parse one single color from the hexadecimal sequence. So basically, we just want to read 2 hexadecimal characters and convert that to a color, in this case, a U8. So we represent it with a U8 value. Why do we have this signature? Why do we take an input and we return this iResult with another string So what does it mean, this particular string, and something else. So the idea is that it is an incremental parser. So every time you read something, you are effectively consuming a little bit of the input. And of course, consuming that part of the input is something that could fail, because if your input doesn't really match what your parser expects, you're going to have an error. And that's why we have a result, because this can also be an error in case that the input is not formatted correctly, or maybe your parser is not parsing that particular version of the input correctly. But then one case is the error. What is this string and what is this value? So the string is effectively, you can imagine it as a tail. So you are reading an entire string, for instance. You're not going to read it all in one go. You're just going to read a few characters, as many characters are needed for your particular piece of information you're trying to process. But there might be more characters left over. So you can imagine that whatever is this string here is basically the tail of whatever was left over to parse. And then this other value can be different for every single parser, and is basically the type that you are parsing, the portion of the string that you have been consuming into that particular type.
So basically, we have this stream of bytes, and take while mn, the function there, takes some bytes and makes the pointer in our tape in our string go on of, in this case, we take 2 and we go on by 2. Because something that happens often with parser is that you want to look forward, so you can take 3, but then move just of 1 or 2, not always by 3. So we already have this kind of freedom here.
Exactly.
That is not that trivial. Typically, when you consume a stream, these having 2 pointers that progress at different speed is one of the most difficult part to implement. And here is for free.
Yes, so the beauty of this library is that the interface itself is very simple. And then on top of that, you have a collection of helper functions. Like you see this mapres or this take while mn, and there are like hundreds of them. They try to implement all the most common things that you might want to do when parsing some input. Like the one you just said, there is even a look ahead. For instance, in binary protocols, it's very common that you have a number that tells you how many bytes do you need to read next. There is already a combinator for that one. It's like look ahead, read the next byte. That byte is a number. Use that to read the next n bytes. So
there was a very interesting advent of code last year, not this year, not 2022, 2021. You remember the one with you have this binary string that contains packet. This is a couple of mathematical operation. If it is a 1 bit to 1, you have to do this. If it is to 0, you have to do that. Yeah, remember that?
Yes, and it was like nested packets. So
it
was getting very complicated, and you needed to read bytes in a different way depending on types and then lengths. It would have been interesting to do that one with Nom.
Yeah.
I think we implemented our own parser by hand.
Oh yeah, we did. It was quite dirty.
Okay, so another example I want to show you here is how things can be combined. So again, these are two different parsers, right? X primary is just an X color is basically 3 numbers from 0 to 255, red, green, and blue. And there is an hashtag in front of it. So what the author is doing here, they are creating a specific parser just for the single unit, so one of the 3 colors. And then they are combining everything together in another higher level parser, which is called xcolor. And now, interesting enough, what they do here is basically saying tag means it needs to match exactly whatever string is in here. So this is basically saying when you start parse the input, it needs to start with this value. If it doesn't find this value, it's going to fail with an error. Then what you get as return is input, which is the remaining string. So it's effectively consuming the first character, and it needs to be an hash. And that will be saved into input. And then here you might have another value, but tag doesn't really return anything. So it will return basically the same string here, which we can just ignore. So this is just a way to say strip the first hashtag, but make sure it's an hashtag as well. If it's not an hashtag, just raise an error or return an error type. Then the next step is it's using basically a tuple, and it's basically parsing this tuple, every single item of this tuple. So this is also interesting that you can parse a tuple multiple times. So it's basically providing.
So that one on the right is a tuple of functions that return an high result, right?
Exactly, and you can.
And and you can implement functions on top of tuple of your type. I was
So
not
this,
aware of this in Rust.
yes, you can. And this semantically, what this means here is like it needs to parse things in this precise sequence.
Yeah,
And the
yeah.
sequence is just 3x values, basically.
Mhm.
There are
It's
other.
possible to see the signature of that parse function where it's implemented in the code of Nom, but probably later, not now.
Let's. I think it's a trait here.
Okay.
I think it's this one, parser. I might be wrong. Yes, I think this is the one. So basically, what it's saying is that a parser is. It needs to have this function, parse. And this function parse takes a specific type of input, which is a generic. General is going to be a string, but it can even be some kind of binary, or it could even be like a streaming format. Maybe you're reading data from, I don't know, an HTTP socket.
Mm-hmm.
So you could even build a parser that parse that value incrementally as it comes through the network. So this is a very generic input, but let's, for simplicity, just think this is a string. Then you have output, which is that particular parser. What kind of objects, what kind of structs is it gonna produce? And then error, if it fails, what kind of errors are you gonna return?
Okay, thank you.
Then you can implement this trait on tuples or
On
whatever
whatever,
you
yeah.
want. Yeah. So going back here, so this is basically just to show that the mindset is that generally you start from the smallest, simplest thing you could parse, and then you combine multiple parsers together and build effectively like a description of what do you expect to find when you parse the data. So yeah, and this is an example. So if you parse X color of this thing, it needs to be an okay. You see that here means that consume the entire input. So the leftover is an empty string. So you always have the tail after you parse. And then you get the color in a struct, which is being created here effectively.
Yeah, probably is a little bit early to ask this, but I'm curious. What happens if you are in a point? Think of a language parser. You can have some stuff that are ambiguous until you don't look ahead, or until you don't. You can take different roles when parsing, and one will fail and the other one will succeed. Is Nom able to detect this kind of stuff at compile time? Is allowing that? Is throwing an error when compiling?
Okay, let me show you here. So for instance, we have, where is it? Modules.
For example, in the even the CSS example, you can specify sharp and six values, or it's also valid to specify sharp and three values.
Or you could say blue, red, green, black colors with like the nominal value. So you could even have a list of those. Yeah. So there is this thing called branch, and this is another parser combinator called alt, and this is basically what you would use for cases where you might have
this or that.
Yeah, different paths effectively. So for instance, here is like it's either a alpha 1 or a digit 1, right? And an example is it can parse ABC and it's going to return ABC, or it can parse 1, 2, 3, 4, 5, 6 and it returns 1, 2, 3, 4, 5, 6. but it doesn't parse an empty, just a space. And you could, here, these are other parsers that are just like one, I think alpha 1 and digit 1 are one or more alpha characters, one or more numbers, but they could be arbitrarily complex parsers. So they could be, I don't know, an if statement rather than a while loop.
Your custom ones. Okay, cool. Thank you. So it already handle all of this.
Mm-hmm. Now, I have to admit that I still trying to learn all the combinators. I think the trick to get proficient is to try different exercises and learn all the different combinators, or even look for instance, Advent of Code. I'm seeing a lot of people trying to use Nom for parsing. So even look at other people's solutions, you will see very different ways of using Nom. So that there is a little bit of a learning curve.
It's interesting there that say that you can combine 21 parsers in every alt. 21, a number like that.
Probably there is some limit in, I don't know, the smack. Yeah.
But it's probably to avoid the allocations. He's keeping an array of 21 something and using only some of them. And you have to use nested one if you want to go in more complicated scenarios.
Yeah, or maybe it's the maximum size of a tuple. I have no idea.
In Rust, there is a maximum size of a tuple?
There might be. Actually, I don't know that one. If anyone in the chat knows, drop it in the chat. Because
anyway, it was just a 21, a strange number like this. Why not 42?
Okay, should we look at an example?
Yeah.
Meaning trying to build something ourselves.
Okay.
Okay, so first thing that we need to do is cargo add nom, right? We need to install it. You can see that Rust is super fast.
Well, compiling and those kind of stuff are a little bit the weak point of Rust, if you ask me.
Yeah, and this is definitely going to be faster than our Bevy experiments. Like compiling Bevy was taking like 5 minutes the first time.
Yeah, compiling time is not the strongest feature of Rust.
Also, when I'm streaming, my machine gets a little bit slower, so that adds up as well.
Okay, please send €5 for a proper streaming machine for Luciano.
No. I think this one is good enough. It's just...
You don't want 6 laptops in front of you?
No. I already have 3 screens and it's too much. Okay. So meanwhile, let's try to think, what can we parse?
Oh, good question. Is it too complicated to parse mathematical expressions, or do you think it's possible?
Let's try something simpler first. Let's try something like, I don't know. Hello, my name is blah. Let's say X, and I am Y years old.
Thank you, Copilot.
So, Tommaso, I see that you are in the chat. So let's try this example, but you have to reveal your age. Okay, so let's start to write a parser for it. And we can do like a struct. Let's call it person. And this struct has a name and age. I like it. Actually, name could be an str because we can keep a reference to the initial string.
Why static? Because
Copilot decided to do it static. So we need to create the parser for it. So let's say fn parse person. Look at that. It's already doing everything for us, but without using nom. So this is actually a good... Let's keep this one in a comment because we will see the difference between this one and nom. So fn parse person. Okay. Input is going to be a string.
A reference to a string, yeah.
And rather than returning a person, we said that
iResult
a
from
parser
before.
is an iResult. What is the first type? The same type as here.
Reference to string, because we have to pass back the leftover of the string of the
And then,
input.
exactly, and then our own custom type, so person. So the type that we want to parse into.
Mm-hmm.
Okay. So now it should complain that we need to import this iResult from nom. Okay, now we haven't done this yet. So we can do a few things. Let's remember our input. Tommaso is 32. Thank you, Tommaso, for being our guinea pig. So this is the input. So we can do this in a few different ways. I've seen different styles. I think that the simplest one to digest is the one where we incrementally consume the string. And then we will see a more functional approach where you create a bunch of subparsers and you combine all of them together with like a list of parsers or something like that.
Okay.
So the more, I guess, imperative approach should look something like this. So we can do something like let input and nothing could be tag, and the tag is everything that we might want to skip first.
And if we want to just look for my name is, excluding everything before my name is there a way to do that?
Repeat the question. If you want to look for,
If I want just to look my name is, skipping everything before it, is there a way to do so?
I think there might be basically.
I want to parse my input until I find my name is. At that point, I know that I want to take it.
You could do that. I'm not too sure what's the best way of doing it, but basically you can do like a take while you start to see my name is, basically.
Okay, let's do that in later. Let's start with this.
Okay, so basically tag is a way to say it needs to match exactly this content. If it doesn't match, it's going to throw an error.
Okay.
So now notice here that we are using the question mark. So this is a parser. So this creates a parser that says it needs to match exactly this string. And then we are invoking the parser on our current input. So this parser already returns something like this, but in this case, it's going to be a string and another string. So here we can say something like tag, for instance, and you can see that the tag is another string. Now the tag is going to be exactly like this, so there is no point in keeping it. We're not interested in that. Now this is just a way to get all this part out of the way. Now we have the name. So let input name is suggesting this, but of course this doesn't make any sense because we want something generic. And nom gives us things that we can use. For instance, alpha 1 is all alphabetical characters, and it's at least 1 and n of them. So this is gonna read until the space. Okay. So this is like a slash d. Sorry, a slash w? No, what
W,
is it?
slash W, yeah.
Yeah.
Backslash W plus.
Yes.
Plus, or an empty string is not a valid string.
No, you can put alpha 0 if you wanted an empty string.
Okay, so it's a plus. Okay,
it's like a plus, yeah.
Backslash W plus. Okay.
Okay.
No problem in shadowing input at every line.
No problem because Rust allows that, and we don't care about keeping the results.
Previous inputs, okay.
Now Copilot is doing the work. let's see, figure out the next
Thank you,
one.
Copilot.
I liked this one because I can never remember this one, but Copilot is doing it correctly. So there is, of course, another parser combinator to parse numbers.
And
In this
get
case,
them not as a string, but as a number.
exactly. We will see here that age is a U8. Now, do we want
Instead,
a U8?
if you do digit 1, instead it will give you back a string. If you are using digit 1 input,
It will give you a string, exactly.
it will give you a string. Okay, no, but we want an integer number.
Okay, and then
in our structure, what was the age? A U8?
In ours, it was a U8, yes.
You're not taking into account vampires and everything else.
People older than more than 255 years, yeah.
But I think it's fine.
Okay, so at this point, the last thing we need to do is, okay, we still need to return the inputs.
Do we have to parse the tail that years old?
So this is more on us. It's like, do you want to consume the input fully? Like, is that what you expect to be a valid string?
Okay.
Thomas is saying, but 0 is allowed. 0 of age, you mean, right?
But 0 age is fine. U8 contains 0.
Yeah, I think so, unless I'm not getting the comment.
And -1, yeah, doesn't make a lot of sense.
Now, we didn't like this one. Why? Oh, U8 can only do a char. What do we have? A U sides?
Why can only do a char? Sorry, U8 is a U8 binary. Is a binary U8.
Recognizes an unsigned 1-byte integer.
Yeah, okay. But it's 1 byte. We have to do the parsing of the string to integer. How do you do that?
Is there, I don't know, either to two?
No, but I think the problem is different. You have 3 2. Those are 2 bytes, and 3. The value of 3 is 51.
Okay, so
and 2 is 50. So even if you parse a 16-bit, is parsing 3 and 2 like 2 binary bytes that have an integer value. So we want and then string to integer.
Okay, let me check this one because I can never remember how to parse numbers with Nom.
Here you are parsing a binary stream. You're not parsing up.
Yeah, there is a way.
Number. But it's nice because you can, like you said, you can parse binary string quite easily like this.
Yes, but there is a way to also, there is a shortcut to also say take the string and just parse it as a number, but I can never remember that.
A to Y.
So nom parse a string.
It's like an X digit 0, but it's not X, it's a decimal.
Probably, yeah.
It's similar to the X digit 1, but it's just
integers.
Yeah, with decimal.
Ooh, seems too complicated there. I remember there was an easier way. Okay, let me see if I have it in my advent of code. I think I've done something like that. So
this one is the send one?
I think so. Okay, here I'm doing digit 1.
And then you are parsing.
Oh, and then I'm parsing. Okay, that's one way, but I'm quite sure there is another way. Let's do this one for now.
Can you show me just a second in the Nom documentation the X digit 0?
The digit 0?
The X digit 0, X digit 1 that are on the left there.
This one, right?
Yeah. What is giving it back?
recognizes 0 or more ASCII hexadecimal numerical characters.
But it's giving back a string?
Is giving back a string, yes.
Okay, nothing. I was expecting something else. And what else do we have there?
So it's like digit 1, but with hexadecimal, basically.
Okay. Nothing. Let's extract with digit 1 and parse for now. Okay, good.
Okay, so what we can do is basically saying digit 1 input.
At this point, age is a string and not a U8.
This is going to be a string for now, so it's going to complain that here we cannot just assign age, but then we can do
age.parse in line 28, 27. Age.parse, yeah.
We shouldn't unwrap, because if we cannot convert.
But if he can convert digit 1, why should not convert if digit 1 only extracted digits?
Because it might be bigger than a U8.
Ah, right.
So we can do map error, I think. Then nom error, yeah, probably. Probably there is a better way of doing this.
There should be something in Nom itself. Is a quite common use case. I want to parse a number written as a string and get the decimal value of it. Makes sense.
Okay, let me look up the other one, because I'm quite sure I did it in a
In the
different
example
way.
about RGB values, what was doing? The example you were showing at the very beginning.
It was keeping it. Actually, yeah, good point.
The example X.
Here U8 is X digit. So U8 from string radix. Oh, it was returning a result.
It was defining a parser for a number. How do you parse a number? You parse a number this way.
And from X, where was being used? With map_res. Okay, that's how you do it. So we can use map_res.
And is X digit tells you if a character is between 0, 9, A, B, C, D, F.
Okay, so here we can do...
again is too much. Let's do this for now. We can...
Wait, map_res.
You want to do that?
Yes. And
the input was not outside of the map_res?
The input was... So this was the parser that was being used, and the next one is the function to use to map.
No, but you see, input is passed to the result of map_res.
Oh, yes, you're right.
In take while nm is take bytes while this function is true.
Something like this, and here we want to use U8 parse.
Oh, show me again what was the example, because I got lost.
Okay.
Show me the example, the other side.
Something like X parse. 1 second. Now we can import map_res. And X needs to be str. Does that make sense?
Show me the example again.
Yes.
So the first parameter of map_res is a parser.
The second one is the mapping function, and all of that creates a new parser.
Okay. Cool. Thank you.
Okay, we have a lot of activity in the chat. Sorry for ignoring the chat. We were too focused on solving this. So we have WGAFFA. Hello, how are you? and Allevo Tommaso suggesting to use anyhow. I don't think we need to use anyhow. I think this is the beauty of this library. It takes a while to learn all the combinators, but when you do, it's very flexible. And you are correct in saying that it's just a fancy way to write regular expressions, but I think it's a little bit more than that, and we will see in a second why.
Yeah, because it can error if the input is malformed or is not behaving like you expect. A regex typically is not matching, but it's not telling you why it's not matching. This one can tell you, okay, I was in this point, I got an error parsing a number, I was expecting a number, I got a string.
Exactly.
Error. A regex is not doing that. It's just telling you, I matched nothing. Figure it out on your own why.
Okay, let's see what happens if we do this. Why?
Unused result.
Okay, fair enough. I don't care. It's just a suggestion at that point. Okay, this is returning a result which contains a tuple where the first item is the remaining stuff and then our object. So here, if we say, and I like Rust, I think Tommaso likes Rust. Tell me if that's not correct. We will see that the remainder is, and I like Rust. But then this is what we managed to parse with our parse person.
Now I will make it more difficult for you.
Okay.
Okay. Parse another string, copy and paste it from 36 to 38. Now, hello, my name is Roberto, and I like Python, and I am 44. No, but put Python, yes, Python then, and I am 44 years old. Also add years old.
Yes, let's keep the same.
Yeah. Can you parse also this? Can you write a parser that can parse both of them? Also add language in the person.
Yes, now this one is going to explode. Let's see.
Oh, I hope so.
But the thing that I want to see is that it explodes by telling you exactly where it stopped, and I like Python. Now, at this point, it didn't match anymore what we were expecting. And it also tells you code tag, which is effectively which parser did fail. And in this case, we were using a tag here, and I am, we found and I like, basically. So yes. In this sense, you can tell that it's already better than a regular expression because it gives you more fine-grained errors. Like a regular expression, either it matches and then you can extract data from it, or it doesn't matches and it's up to you to figure out why it doesn't matches, and debugging it is a bit of a mess. So this one is a little bit more advantageous because of this.
Tommaso was asking about lifetimes.
Is it important that, let me put this one on screen so everyone can read it. Is it important that person is binded to the lifetime of the input? Could you use string for the name of the person? Of course we could. We just wanted to avoid the allocation because at the end of the day, our strings here are static. So this way we are just keeping a sliced reference to that particular part of the string.
Yeah, if we were parsing a streamed content instead of a string in memory, it could have made sense to make a copy because once the stream is
you
consumed,
might lose it. Yeah,
it's gone.
Let's do it as a string just for simplicity.
While you are there, also add a language to the struct.
Yes, let me fix this
Programming
first.
language, not a spoken language.
Now this should still work. And now let's add programming language. Still, we keep a string for simplicity, so I don't have to add the lifetime again. Actually, now we can simplify here. Okay, now of course this doesn't match anymore. Now is where we need to start thinking about how do we handle two different paths, right? So let's pick the two examples.
There was permutation also in alt. In the documentation, there was alt and permutation.
Yes. So the first part is always the same. Well, here let's add and I like Rust. Okay, so this part we can probably standardize it. So let me think about this. Because we also want to find both of them, right? They can be in swapped order, but we also want to find both.
Yeah, and for this reason, I was suggesting to take a look in the documentation at permutation, because the name suggests something like this. It also suggests that because it's on the same level of alt, it was in the same page of alt.
Okay, so it's in modules, and then there is branch, probably.
Yeah, it was under branch.
Permutation.
Yeah,
What
the
does it do?
name suggests me something useful.
Applies a list of parsers in any order. Permutation will succeed if all of the child parsers succeed. It takes as argument tuple of parsers and returns tuple of the parser results.
In any order, so cool.
Let's see the example here. So what they do here, they have an alpha 1 and a digit 1 input. And it returns ABC and 1, 2, 3, or 1, 2,
1,
3
2, 3
ABC, but it returns them in the right order. So this is what we
in the
want.
order you say. So yeah, so we have to do an age parser and a language parser,
And then use permutation.
and then use permutation on top of those two parsers, and it will give you the right stuff.
Okay.
And already here we can see that the approach, like you said before, the imperative approach of parse this, and that here is already failing because it can't do the permutation. To do the permutation, we have to use the structured approach.
Exactly.
A more functional approach if we want.
Actually, age is going to be U8. And let's put a to-do here. And then fn language parser, for lack of better name.
In the chat, they say Eulen's. Oh my God! Please read that name, you, Luciano.
Eulenspiegel. This is how I read it. Sorry if that's not correct.
Right. Sorry. Say if we parse. My name is as a parser. I am this years old. I like something. Those are three different parsers, and we can swap them in any order. Then they could be we get rid of hello, or we assert that it starts with hello, and the end preposition in the middle of the free parse of the free permutation they go down for free. I mean, yeah, it's something that we can do.
Let's do that. I like it.
Let's start just with age and the language. Let's add the name parser later, because let's start simple.
So let's start with hello, right? And then what we want to do is basically say let input, and we want to say bunch of things. We will decompose them later. Is going to be permutation of language parser, name parser, and age parser. Let's do name parser first. Age parsers and language parser. Okay, now
and
permutation needs to be.
And they must all match, right? They can't be optional.
Why it doesn't import? I think they must all match. This is what I understood from the
documentation
example.
say that they should all match.
Permutation, nom branch permutation. Oh, it's there. So why is it complaining? Oh, maybe they need to have all the same type. Is that the thing?
No, don't know.
Let's try very quickly just the name and the language, which are both string. Is that gonna work? No. So why is not happy with it? Am I using this wrong?
You have to pass a tuple inside permutation. Have you opened the two round brackets?
Oh, good catch. Yes, good catch.
No, you
So
open only one. You have to open twice and close twice because you have to pass a tuple, not
good catch.
3 parameters.
And you can see that here is already giving us a
Yeah.
string. You ate a string. So what we can do is name, age, language.
Can you create a person directly there?
I have seen somebody doing it by implementing a function called parse in the struct person, and then they just do this inside that function.
Okay.
And basically there they do person.parse, but it's a little bit more indirect, I would say.
They made a parse function from the tuple to the object.
Exactly. Yeah. It's
Nothing
just
fancy.
Just an indirection. So at this point, we can get rid of all of this. I'm going to comment it out because we're going to move it to the other function.
There is a typo in the chat. They say that there is a typo in the name of the function language parse. Thank you, guys.
Good catch. Rename. Language.
On the Mac is Command Shift F6.
Okay, language is language to string. Oh yeah, now we said they are going to return strings already, so we can just
we don't have to cast them to.
And at this point,
you can remove the colon stuff. Yeah.
Awesome. So this is what we want to get to. Now let's do the
end. How do we handle the end?
There is another thing which is separated list, I think. But how do we combine a separated list with a permutation?
Can we say in the parser that something is optional?
We can.
I mean, it can be and I like Python or just I like Python. And also the I is not capital, but I don't know if you want to do case insensitive tag. Because you can match and I like Python or only I like Python. So the end space is an optional tag that can be there, but if it's not there, cool.
We can do an optional tag. I think it's actually called optional. Arguably, like, does it make sense as a syntax? Let's decide yes, but you could have different requirements depending what you're building, right?
Oh, obviously, but it was just to handle that in a not dirty, but dirty.
Another thing that I've done for Advent of Code is, together with this permutation, there is another one called alt, which does the same thing, but basically it tries to run a sequence of parsers that you can provide, and the first one that matches is whatever is going to return. So that's convenient when you want to parse.
When you don't know what you will find.
Exactly. So another approach could have been, if we wanted to have a more loose syntax, where maybe you can just stop at my name is Tommaso, right? So you could have an arbitrary sequence of names, things you like, ages, if that made sense. You could have done it with a separated list of alt. The only trick with alt is that they all need to return the same type. So generally you need to do an enum and manage all the different variants in an enum.
Okay, but let's not do that. Let's go simple for now. So
okay, so let's say that my name is, that's easy. Let's just copy it from here.
Yeah, it's a tag. My name is that you deleted. So
I deleted it, so I'm gonna do it again.
You're writing it. That is the name.
Let
input, comma.
My name is, okay, thank you, Copilot. And alpha 1, and then, okay,
Then you have to return a string. Yeah, okay.
That should be it, right?
Mm-hmm.
Now the other one, let's do the age. Age we can copy it from here, but we need to add the end as an option.
Yeah, copy also line 45. No, there was you forgot to copy the tag.
Sorry. And I am, yes, you're right. So all of it.
Yeah.
At this point, we can delete this one. Okay, so this was the age. So let's do the optional one.
Tag can be case insensitive because there you wrote a lowercase I and instead of an uppercase I. Can tag be case insensitive?
There might be another one that is like tag insensitive. Let's check.
In chat they are asking 1000 stuff, sorry.
Tag no case. Look at that. Tag no case. So recognizes a case insensitive pattern.
Okay.
So
I was saying that in the chat there is suggestion about doing and or a comma, and WGAFA was doing, can't you do something like tag and then? But what? Let's fix it then.
I'm not too sure, but let's see. Let's go step by step. Let's see where we get.
Yeah.
So here we want to do opt, I think. And opt says tag, okay, and I think that's the way it works.
And then in line 25, you have to remove the end.
And we need to remove.
There is, do we need a space before the end in line 24?
I think we'll do it this way. Like we definitely want a space here, but do we want a space here as well? Yes.
Okay, cool. And you don't need the question mark at the end of line 24? Or you need the question mark at the line of end 20 line?
We need the question mark. We do. Do we? I think so. Okay.
And you need the comma underline in line 24 also, no?
And here, wait. I understand now. So this is going to be...
But we don't care about that.
But we need to ignore it because otherwise the input gets messed up.
Mm-hmm.
So this will return an optional string only if this one matches.
Okay, so there is an optional end. I am, then there is our age, and then there are years old. Okay, cool.
And then we can return an okay of the remaining string. So the input and the age. Make sense?
Yes.
Cool. Now language parser is the last one. So let input, well, I suppose we can copy the first line.
Yeah, the first two lines.
Then this one becomes and I like. And then we do language alpha 1.
And then we return an okay to string.
Let's see if now both work. Ooh, it didn't explode, I think. Roberto, age 44, likes Python. Tommaso, age 32, likes Rust. Okay, now I'm gonna try something else. My name is, okay, let's just say I like JavaScript. My name is Luciano. Without the end. I with uppercase. M. Let's see. I'm not 22 years old.
I'll Copilot.
Thank you, Copilot, for making me young. Let's see if that works. It didn't work. It did explode. So let's see if we can make sense of it. It did fail straight away at the very beginning. A low comma. Is it? Why is that? What did we say? Oh, no, wait. It failed in I like JavaScript. So this one was okay. It did fail in I like JavaScript. I probably didn't put the no case somewhere
Yeah, there is a.
here. So hello, let's make it no case at this point.
Also line 41. My name is.
Let's make everything case insensitive.
What is the?
Here is everything tag no
There is a
case.
space in front of the I in I like. There is a space in front of line 34. There is a space that should be there.
Yeah.
If remove the space there and put the space at the end of the end in the line above. Remove the space from there.
Why is it's not the same as this one?
Because a low comma space. And then is expecting two space after the low comma. Remove the space there and put space and space in the line above. Do the same in 24 and 25, just to keep consistent. No, the space should be before and after the end. No, don't remove the space.
Before and after?
Yeah.
And like this. And okay.
Cool. Try again. Yeah, parser are hard.
Still doesn't like it. So we got as far as my name is Luciano and I'm 35 years old.
We went away. We went on. Because he was expecting you have to put an optional end in front of my name is and say I like JavaScript and my name is and I am.
Yes, so the parse person doesn't have the end in front of it, right?
Mm-hmm. Yeah.
The parse name, right? Where is the name? There.
Somewhere.
Okay, so let's try again now.
Still not sure about spaces here. Yeah, because you are expecting an end or my name is, but there can be also be the case of just a space.
Okay, we can also add spaces, like arbitrary spaces, as many spaces as possible. But
yeah, can we not consider the spaces in our parse because we don't care really?
Yes, we can do that. I'm just not sure. I think it's something like spaces. Space 0. So what we could do here
is space 1. Space 1 means at least one space.
Okay, let's do this. We need to do space 1. Tag no case, space 1. Doesn't like that.
Do you have to import space?
Oh yes, it's just it needs to be imported.
I don't
and
remember.
Now it doesn't like all of that. There is like a tuple, I think. Now we're gonna have fun with a lot of parentheses. Okay, that should work. Now let's do a quick thing. Let's just do an
end parser. Somebody is asking in the chat, regex are implemented with parsers? No, they are state machines. Strange beasts.
Okay.
We don't care about.
That should eat any end for us.
And now we have to use it.
So now we can replace all of this with the end parser without
Yeah,
end.
but we don't have still the problem with the space in front of my name.
Yes, but we could probably do the same. The space in front of my name. Where is the name? So we have end parser, language parser, name parser. So here we might want to have an optional space, basically, right?
Was not our last problem, that one?
Mm-hmm.
Yeah, an
So
optional space there.
we want to do tuple of opt of space. Actually, we don't
What?
need to. We can do space 0,
Okay.
right?
And tag no case. Okay.
Now we
You
need
have
to
to
add
open
all.
double round bracket. Yeah.
Okay, space 0 needs to be imported. Let's see if we got it right this time. No, but we did some progress.
Yeah, now we are on the age because we have the same problem with the space with the age. So we have to copy and paste the approach with the space 0 in front of the age.
Language parse person, age person. So years old, year, right?
No, in the I. There, you need the tuple space 0 I.
In this eye, in front of this eye, right?
Yeah.
So we want to do tuple.
Two round brackets. Space 0 comma that one and close.
Okay, we do have lots of activity in the chat, but let's try this first and then we'll get to everyone. Sorry for that. Ooh, works.
Yeah.
Oh, but this one broke. And I like Python and I'm 44 years old.
Which one
And we
broke? The
also
Python
broke the
one.
other one. And I like Rust. Why? Code tag.
Go up in the language one. That stuff about the end is not working somehow.
Maybe we should rethink the approach. Okay, let's pause that for a second. Let me check the chat.
Yeah, sorry.
Okay, so we have Altos, by the way. Welcome to the stream. Thank you for joining us. Yes, this method seems pretty manual. So yeah, I've seen that some old examples with Nom, they were using a lot of, rather than using plain functions, they were using macro-based syntax, so the exclamation mark. And it was a little bit uglier to see. So this one is a little bit better. This method seems pretty manual. I'm not sure what you mean. If you know other methods, let us know. We are trying to follow an approach where it's a little bit imperative, if that's what you mean. Like we go step by step, and then we use the new combinators that we are learning as we go to kind of make it a little bit more functional and composing multiple things together.
Can you revert line 47 and 39 to what they were before?
47. This one?
Yeah, that was I tag space and space.
Tag no case.
Tag no case, sorry. Space and space and
I am?
no end.
No, I like.
End. Space, close, yeah, that one. To skip the end and do the same in line.
Here, right?
Yes, there.
Okay.
Also, we are missing the space 0 in front of I like.
So the first, everything is broken now. We are
Perfect.
missing the space 0 in front of. Oh, here, maybe that's the issue.
Add the space 0 in front of that with the tuple space 0. Yeah, that's syntax. We have that in all three of them. Let's check it.
So 3 of them here, yes, I am.
Okay, let's try again. What's happening now? One was failing on hello. I don't know why it was failing directly on hello.
So they are all failing now. Let's try to fix them one by one. Let's fix the first one.
Okay, the first one was able to parse hello. Then it arrived to my name is and died there.
It didn't like it, yeah. So why is that? If we go
my
to
name is should match the name parser, right?
yes,
The name parser say there is because
now it's
case,
expecting the end anytime.
it was OPT. You forgot OPT.
Okay.
It was OPT that not.
Sorry, not here, but here.
Change that in all the places because it's the same. Yeah.
And this is what we believe we have abstracted with the and thingy.
In the first one too. Scroll up.
This one was correct.
This one was already fine.
Okay.
So all three of them are fine now.
Let's see. Oh yeah, now it's working.
Tommaso is working. All of them are working. Okay.
So what did we do wrong here with this OPT thingy?
Mm-hmm.
We did this function end parser, which was supposed to do
the same stuff.
Oh, but it is different.
Yeah.
We didn't implement it this way.
No, we say the space, any number of space and any number of space. But it's still optional. Instead, that is end parser.
The end needs
optional.
to be there, yeah. So let's copy this. And let's replace
and use the end parser. Okay.
If there is a Vim user here, it's gonna kill me.
Yeah.
Okay, this now should still work. No.
Nice. But what's happened? What?
Code tag.
But it's not exactly the same. You copy and pasted.
Unless I did something wrong.
You mean you're calling the end parser? Scroll up to the end parser. In the end parser is copy and paste of that. I can see it. Scroll a little bit. Okay.
This one.
It's an optional. But there is no space 1 and space 1. No.
Oh, I know what I did wrong. I'm an idiot. Let input. We were losing the input. We were returning the previous input.
Okay. Yeah, you always have to do that.
Yeah.
Let the input.
You always need to do a little bit of a dance.
Yeah.
Okay, now it's good.
Okay, here I have a question. Having to skip duplicated space is something that you do quite often when you parse stuff. I mean, if you parse even languages, you don't care, except Python, when you intend, but you don't care about how many spaces are between words. Is there a way to tell Nom, look, don't care about spaces, I just care about full strings?
I think you'll need to build something like this.
You need to build something like this, okay.
Yeah.
There's not a verbose mode or something like that.
Yeah, exactly. Now here, because we are using tuple, we could even combine everything in one tuple, like as a sequence of things, but doesn't matter. I prefer it this way.
Okay. Tuple and parse space 0, tag no case, and parse everything in front of it. Okay.
Cool.
Look, the wgaffer suggests to look at the function delimited. It probably is a nom function.
Delimited. Okay, that's a good one. And then we have also for any white space, not just space. If there is a new line, there won't be a space, for example. Yeah, there is, I think, another one. So there is multi-space, which recognizes space, tabs, carriages. I don't know if it recognizes
Everything.
new lines. And line fits. So multi-space is kind of the more generic.
The carriage return,
If you don't care about
CRLF.
any spaces. Then the one delimited. Delimited, what does it do? First, second, third. Oh, this is when you want to, for instance, remove parentheses around something. Like, for instance, ABC, you don't care about the parentheses. You just want to be sure that they are there, but then you don't want to keep them, and you just want to keep the content. So it's basically allowing you to say, there needs to be something before, something in the middle, and something at the end, but you can disregard the before and after and just keep the one in the middle.
Okay.
There are also variations of this one. There is one that I think is like starts with and ends with, or something like that.
Yeah, but this one is taking also stuff in the middle.
That's the one.
Okay.
Preceded and terminated. It's kind of the same idea when you have a prefix. We could have used that for the and.
But it's optional.
You can wrap it in an opt as well.
Okay.
So you.
Oh, well, anyway.
Yeah. Long story short, what is the summary of everything we saw today? Because I think it's time to start to wrap up.
We saw that Nom as a parser give you meaningful errors.
Mm-hmm.
We saw that there are ways of doing that a little bit more programmatically and more functional, and there is a lot of documentation to read because you need to know all the functions. Otherwise, you will find yourself writing stupid stuff because you don't know all the functions that Noms provide. Right?
Yeah.
We learned that regex are good, but they don't tell you this. So it's a little bit less. And also the permutation with a regex will be, it's possible because it's multiple group, but then you have to do multiple group capture and is a little bit painful to parse all of.
And you will need to
cycle on top of the matches. Look if the match is of one type, allocate. There's a lot of additional if conditions and checks. In this way, all the conditions and checks are done by the parser itself.
Also, all the other regular expressions are eager, meaning that you run them on the entire input, or it's on you to run them progressively, like you need to kind of feed them as you go, which gets very complicated. So with this approach, you have something incremental. Basically, it's going to consume the input as long as it matches, and it stops when it doesn't match anymore.
If you show me the code a moment in the import section.
Yes.
I had a question.
Oh, we can remove tag. Space one.
That there is that complete. I saw that there is complete and there is stream.
Mm-hmm.
And then there are functions, for example, tag no case in theory is in the stream and in the complete. So there are two versions. I suppose the stream is for streaming instead of having a buffer already in memory. Right?
This is my guess as well. Maybe it's able to work with some kind of stream type where it can request more bytes if it's kind of gotten to the end of the current chunk.
Okay.
Cool. But I don't know for sure. It's a guess as well. So something worth double checking.
Nice, because if you are going to parse 8 GB of text file, you want to stream the file, you don't want to load it and parse it.
Yeah, or you could probably parse even stuff on the fly, right? Maybe you are playing, I don't know, getting a video and you want to display frames as you get some bytes of it, not like buffer everything up front.
Nice. Yeah, I think for today we can sum up here. So, do you want to
Okay,
do closing?
so yes, so this is actually a very different one from the other ones. We don't really have any link or any stuff to point you to except, again, our YouTube channel, which I'm going to be posting here in the chat for all the recording. And with that being said, we're going to probably be streaming next week again on Monday. So feel free to be in touch. And yeah, if you have any comments, send us to us either on the videos on YouTube, which we are going to be publishing very soon, probably by tomorrow should be online, or reach out to us on Twitter or in any other channel. You'll find all the links in the Twitch description. So thank you very much. And also feel free to suggest interesting topics if there is some other crate that you would like us to explore.
Yeah,
Otherwise,
otherwise, we will do another a year of advent of code. So watch out. If you don't suggest
exactly,
anything, we will punish you with another year of advent of code.
more advent of code. Thank you,
Yeah.
everyone. Tommaso, W. Gaffa, Eulen Spiegel, and Altos. Today we had a lot of people in the chat, so thank you for contributing. Okay, I'm going to try to do a quick raid. Let's see if we have somebody to raid. Yes. Okay, so
somebody to raid.
see you next time. Bye. Thank you, everyone.
Bye.